All right, welcome to the explainer. So, you've built a prototype for a retrieval augmented generation system, a RAG system. That's awesome. But now comes the hard part. How do you take it from a cool demo to something that's actually ready for prime time? Think of this as a coaching session for a system design interview. We're going to walk through the 5 make-or-break questions you absolutely have to nail to prove you can build a system that's not just clever, but robust, efficient, and ready to scale. Let's dive in.
So here's what we're going to cover. First, we'll tackle that pesky system latency. Then, we'll figure out how to keep the cost down by optimizing our embeddings. After that, we'll get clever with caching, learn how to handle massive data updates, and then we'll put it all together into a full production blueprint. Sound good? Let's get to your first question.
All right, first up, tackling system latency. This is probably the #1 hurdle everyone hits. Your proof of concept is working, it's getting answers, but it's just so slow. Real users won't wait around for that. So let's figure out how we fix it.
Okay, so the interviewer leans in and asks the first question. How do you reduce latency in a RAG system? This is a huge one, a really fundamental challenge. Your answer here needs to be super sharp, so let's break down what a really solid answer looks like.
Okay, first things first, let's get on the same page about what we mean by latency. It's basically the total time it takes from the moment a user asks a question to the moment they get an answer back. And in a RAG system, that delay comes from a few key places. You've got the time it takes to embed the query, then searching the vector store, then re-ranking, which, by the way, is when you use a second, smarter model to double-check and reorder the first batch of results, and then finally, the LLM itself has to generate the answer. Any one of these steps can be a serious bottleneck.
So, a really strong answer here is one that breaks the problem down into actionable steps. Here are 6 solid strategies you can talk about. 1. Speed up your retrieval time. That means using a fast vector DB and being smart about not fetching 1,000 documents when you only need 10. 2. Shrink the context size you send to the LLM. It's simple, right? Fewer tokens means a faster response. 3. Use those re-rankers carefully. They're great for quality, but they add time, so it's always a trade-off. 4. Don't use a sledgehammer to crack a nut. Pick smaller, faster models when you can. 5. Use streaming. This one is huge for user experience. It doesn't actually make the final answer come faster, but it feels faster because the user sees the words appearing one by one. And finally, number 6, parallelize. Do things at the same time, like embedding the query and applying filters. The whole idea, the core principle is just this: do less and do it faster.
Okay, great. Your system is now lightning fast. But then you get the first cloud bill. And whoa, it's adding up and it's adding up fast. This brings us right to our second big challenge: optimizing the cost of embeddings.
So, the interviewer sees you've got speed covered and hits you with the follow-up. Okay, next up, how do you optimize embedding costs? This is a great question because it's not just about tech anymore. It's about operational efficiency. Can you build something that's not just cool, but actually financially sustainable?
And the great thing is, the solutions here are super practical. Let's run through them. First, you gotta chunk smartly. If your chunks are too small, you're paying for way too many embeddings. Something in the 500 to 800 token range is usually a good sweet spot. Second, and this is a big one, don't re-embed data that hasn't changed. Keep track of versions. Third, think about using cheaper, less powerful embedding models if the task doesn't need a top-tier one. Fourth, cache those query embeddings for common questions. And finally, this is just good data hygiene. Get rid of duplicate documents before you even start indexing. Seriously, clean data saves you real money.
And really, it all boils down to this one simple idea. It's a mantra you should just burn into your brain. Embed once, reuse whenever you can, and avoid unnecessary duplication. If you stick to that, you're going to keep your costs under control. It's that simple.
So, we just mentioned caching as a way to save money, but here's the beautiful part. It's also a massive win for latency. It's like a 2-for-1 deal. So it makes perfect sense to dive a little deeper into our third topic: how to implement really smart caching strategies. And of course, the interviewer is going to pick up on that. The next logical question is, so what caching strategies are most effective in RAG pipelines? Now, this is a question where you can really flex your muscles and show you understand system optimization and the trade-offs involved.
The best answer here isn't just one thing. It's about thinking in layers. You start with the basics, like a query embedding cache to reuse embeddings for common questions. Then you build on that. You can have a retrieval result cache that just stores the document IDs for questions you've seen before. The next level up? An LLM response cache that stores the entire final answer for identical queries. This is perfect for things like FAQs. But the really advanced stuff is the semantic cache. This is super cool. It can reuse answers for questions that are semantically similar, not just word-for-word identical. A real production-grade system will absolutely use a mix of all of these together for maximum impact.
Okay, so let's recap. Your system is fast, it's cost-effective, and it's using smart caching. You're feeling pretty good. But the world doesn't stand still. Your documents are going to change, and this leads us to a really critical, real-world operational problem. How do you handle large-scale updates without, breaking everything?
And here it is, the question that really separates the prototypes from production systems. How do you handle large-scale document updates in a live system? This isn't about fancy algorithms anymore. This is all about reliability and maintainability, two of the absolute pillars of any serious piece of software.
I just love this analogy because it makes so much sense. If one page in a book changes, you don't reprint the whole book, right? Of course not. The principle for your RAG system's knowledge base is exactly the same. You only want to touch, to process, to update what has actually changed. So how do you actually do this safely in practice? Well, there's a checklist. First, you absolutely have to track document identity and versions. Second, you use incremental indexing. You don't just rebuild the whole thing from scratch every time. Third, you need an efficient way to spot changes, and that's usually done with content hashing, basically creating a unique fingerprint for every document. Fourth, and please don't forget this one, it's so critical, you have to handle deletions properly, otherwise you'll be serving up old, stale information. And last, you do your updates in manageable batches, and you monitor your quality metrics like a hawk to make sure nothing broke.
Now, here's a really cool technique for doing this without any service interruptions. It's called a blue-green deployment. Here's how it works. All your live users are currently talking to your stable blue index. It's humming along just fine. Meanwhile, in the background, you're building a brand new green index with all your latest updates. You can test it, validate it, kick the tires, whatever you need to do. Once you're 100% confident it's good to go, you just flick a switch. You redirect all the live traffic to the green index, and just like that, it becomes the new blue. The best part? Your users experience zero downtime. It's seamless.
Okay, deep breath. We've covered latency, cost, caching, and updates. We've tackled the big individual problems. Now for the grand finale. Let's put all of these pieces together and draw up the complete architectural blueprint for a production-ready RAG system. And here it is, the big one, the final boss question of the interview. How do you design a full RAG system for production use? This is your moment to connect all the dots and show that you see the entire picture, the whole end-to-end system. And the absolute key to a killer answer here is to think way beyond the simple vector DB plus an LLM prototype. A real production RAG system is a sophisticated end-to-end pipeline. It's built in layers, and each layer is designed with things like accuracy, reliability, security, and monitoring in mind.
So let's walk through the core layers. It all starts at layer 1, data ingestion. This is where you get your data, clean it up, enrich it. You've heard it a million times, garbage in, garbage out. It's so true here. Next, layer 2 is indexing. This is our chunking and embedding step. Layer 3 is the retrieval engine, the search brain of the operation. Now, layer 4 is absolutely crucial, prompting and context construction. This is where the magic happens to prevent hallucinations and make sure you're citing sources. And finally, you get to layer 5, generation, where the LLM does its thing and gives you the answer.
But wait, we're not done. A true production system goes further. These next layers are what make it robust. Layer 6 is evaluation and monitoring. I'm telling you, this is non-negotiable. You have to know how well your system is performing. Layer 7, of course, is security and access control, especially critical in an enterprise setting. Layer 8 is where all our hard work on performance and cost controls lives, including all that smart caching. And finally, Layer 9 is reliability engineering. You have to plan for failure. What happens on a timeout? Do you have retries? That's what this layer is all about.
And that right there, that is the blueprint. That's what takes you from a cool little prototype to a truly robust, scalable, production-ready system. And it leaves us with the one question I think you should always ask yourself when you finish a project like this. You've built your RAG system, but did you build it to last?